Hi, I'm Thomas. Some of you might know of me as a robotics guy. But what you don't know is that I'm also a CTO on an AI startup called Next. I've been doing a lot of research on AI. And here's what I think. We're currently living in a world where Gemini and OpenAI are not the only providers of large language models that we have today. But instead, we live in a world full of open source AI models that you can run on your own computers and PCs and Macs. And it's exciting. However, here's what I think. The future is not on your laptops or computer or Macs. Those devices are already so crowded. The future is on dedicated devices, kind of like this Raspberry Pi here. So today I'm going to be testing out different open source LLM on different single board computers like the Raspberry Pi over here.
To AI.
Oh, we have this too. This is the Lab Potato. A very well priced but incredibly dumb board. Well, let me introduce you to my favorite collection of single board computers. That's not too bad. Yeah. Today's our contenders are the Raspberry Pi 4, the Raspberry Pi 5, and the Orange Pi 5 Pro. These are all single board computers with different amount of memory, anything from 4GB of RAM to 16GB of RAM. We also have different amount of CPU power, and of course these are all priced differently. What I am trying to do here is to figure out what is the appropriate amount of money you should spend to buy a single board computer for a competent performance when running an AI or a large language model. This can help you with a task like building a normal chatbot like a ChatGPT, could be summarizing your information for you, could be helping you write an email, or can be an AI girlfriend, an AI therapist, whatever it might be. And without spoiling too much in the future, the benchmark shows that it's actually much cheaper than you might think.
I agree to everything he just said.
And I have some interesting observation.
What have you observed, Thomas? Tell me.
So, I have an LLM. Okay, now, let's look into our options of large language models. If you look into sources online like Ollama, there can be almost 100 of these language models. So let me help you break it down. Models are typically divided into different families, such as Llama by Meta, Phi by Microsoft, and Small LM by Hugging Face. Each of the family are divided into different weight classes or context size, ranging anything between 150 million to 7, maybe 20, 40 billion parameters. Typically, the larger the model, the more powerful and smart it becomes, therefore running more slowly on Raspberry Pi or not running at all. Okay, today we will be comparing 5 different model families. The first is Llama by Meta, the OGs of first ever properly open source language models, and what kickstarted the wave of open source models in the first place. The next is the Phi family. This is the family of models trained by Microsoft using their learning from OpenAI and a lot of research. Next is Mistral. Honestly, I don't know much about this language model family, and apparently it's just really good. We'll also be testing Gemma by Google, as well as Qwen 2 by Alibaba. And last but not least, my favorite model, Small LM by Hugging Face. These are models trained on extremely small but high quality data to produce amazing performance at a small size. And with that in mind, it's time for some benchmarking. Alrighty. It is the next day and let's get into some actual benchmarking. I will be performing the experiment using a software called Ollama to run any major open source language models with a few lines of code. Let's get into it. Okay, as you can see, I have a Raspberry Pi 5 plugged in and running here. But here, let's tinker around. Let me see, Ollama ls. This basically shows me all the install models. For demonstration purposes, I will show you how to use the small LLM 2 model. So Ollama run small LLM 2 latest. What? Let's do 360 million verbose. Let's ask it a question. Let's ask it a question. What is a Raspberry Pi? That is pretty impressive. That is pretty good. Here's what I want you to focus on. These are the parameters of how well the Raspberry Pi is running these LLMs. There is one number I want you to focus on, and this is the most important number, which is eval rate. This is how fast the text is being generated as a response. You can count almost one token is one word approximately, and 13.74 is a really good number. Let's try another model. Llama run verbose llama 3.2 1 billion verbose. Tell me about the Raspberry Pi in one paragraph. That's actually a lot faster than I expected. Now you see here, this is a significantly larger model with 1 billion parameters compared to the previous 360 million parameters. With that, of course, run a bit lower speed, which at 7.9 tokens per second or approximately 8 words per second. Now, we are testing dozens of models today, and I do not want to bore you with running all of these. So I have previously run all of these models on all of our single board computers for the last few days. Let's get into some numbers and see what they mean.